Hi everyone, welcome back to all of you on my YouTube channel. So, in previous lecture already I have discussed. I have started the membrane separation, and there I have discussed about reverse osmosis, nanofiltration, ultrafiltration, and macrofiltration. And you can see here that I have made a table here, and this tables this table defines the all of these membrane separation process where delta based on the pore size and pressure drop required. So here you can see that the pressure drop in reverse osmosis was highest compared to the nanofiltration, ultrafiltration, and macrofiltration, and the pore size was lowest in RO, and that was highest in macrofiltration, right? So today I'm going to talk about the reverse osmosis and reverse osmosis process. That is also very important for the gate examination, and you can see in last 3 years 2 questions came from the osmosis and reverse osmosis. So if I'm talking about the osmosis, so osmosis is the movement of the solvent across a semi-permeable membrane from a region of low solute concentration to a region of higher solute concentration, right? So let's try to write the definition first. So it is the movement of solvent, if I am taking solvent is water, across a semi permeable membrane from a region of low solute concentration to a region of high solute concentration. But definition is not very much required, but again this all of this process depends upon the definition only. Aiming to equalize the concentration solute on both sides, right? So let's try to understand what is happening here in osmosis. So let's say concentration of solute here is C1 in left side in compartment 1, and concentration of solute in C2. Okay, so let's say C1 is less than C2. So concentration of solute in compartment first, let's say this one is first and this one is second compartment, and this one is the semi-permeable membrane, right? Semi-permeable membrane, and solute is solvent is your water, right? So what will happen, the water molecules concentration is less than C1, so water molecule will start moving from this side to this side through this semi-permeable membrane, and it will start moving, and it will move until the concentration of solute in both sides will get equalized, right? So this process is called as the osmosis. So what is most important thing here, if I want to write the key point for osmosis, and all of these questions can be asked theoretically. So first key points can be only solvent molecules can move, only solvent moves. Solvent mostly here I am assuming is water, so yeah, and occurs through a semi permeable membrane only. Semi permeable membrane. So if any another membrane is there, then osmosis cannot be, you know osmosis cannot occur. So you have to understand whether that is semi permeable membrane or not. If semi permeable membrane is not there, then you can say that osmosis cannot occur. And third one is, since you have seen that since concentration of solute was different, that C1 was less than C2, that's why solvent molecule was moving from C1 to C2, from lower concentration to higher concentration, to equalize the concentration from both sides. So the driving force, or you can write driven by concentration difference, right? So this thing is very, very important in case of osmosis. Now coming to the osmosis pressure, that is also very important point for understanding how osmosis happen. So let's talk about Osmotic pressure. So osmotic pressure is a colligative property, and if you recall the concept of your class 12th chemistry in physical chemistry, you would have stated the colligative property is the property of the solution that depends upon the number of moles of solute. So osmotic property is also going to depend upon the number of moles of solute. So what we have seen there, in osmosis the solvent molecule is moving from a lower solute concentration to the higher solute concentration, and until it moves when the concentration of solute get equalized both sides. So the osmotic pressure is the minimum pressure required to stop the osmotic flow of water across the semi-permeable membrane. So here if you want to write the definition, osmotic pressure is the minimum pressure required to stop the osmosis flow of water across a semi-permeable membrane. Okay, so mathematically this is a colligative property, let's say, meaning that it depends upon the number of solute particles, not their identity. So properties of solute particle is not going to take any part in the osmotic pressure, but again number of solute particle is very important. So if I want to write the mathematical expression of osmotic pressure, this is denoted by pi, that can be written as I into mRT. Is that clear? I into mRT, where pi is the osmotic pressure, pi is your osmotic pressure. This can be in atm or Pascal. I is called as Van Hoop factor. I is called as Van Hoop factor, and it depends upon whether there is dissociation or association of particle, right? So you can also write number of molecules number of dissociated particles per molecules, right? And what is capital M? That is the molar concentration of solute and that can be in obviously in mole per liter, that is the molarity. And what is R? R is 8.314 joule per mole Kelvin, or you can also write here 0.082 liter atm per mole Kelvin. So I think this will be important here. This won't be important, right? So because unit is pi, so pressure's unit is atm or Pascal, so definitely the universal gas constant you should write in liter per mole atm, liter atm per mole per Kelvin. Okay. Okay, and the value of T is your absolute temperature. Kelvin. Okay, so this is all about the osmotic pressure. Now, based on the osmotic pressure, we can have a solution, right? And we can categorize the solution in different forms. So let's say types of solution based on osmotic pressure, right? Type of solution based on the osmotic pressure, and here I'll be talking about three solution. First one is a hypotonic solution. Second one is your isotonic solution. And the last one is your hypertonic solution. Okay, so So when we talk about the hypotonic solution, so in case of hypotonic solution, generally this occurs in biological system. So having lower concentration of solute outside the cells than the inside, right? So if solute concentration outside the cells is less compared to inside, so in that condition what will happen? Water enters the cell and causing the swell or even burst of the cells, or cell lysis will happen. When it comes to the isotonic solution, equal concentration of the solute outside the cell and inside the cells. So in that case, no water is going to, that is no movement of water will be there, and the cell maintains its normal shape, right? And when there is a hypertonic solution, then higher concentration of solute outside the cell compared to the inside. That's why what will happen, the water molecules will move out from the cells, and this will cause the sinking of the cells. Is that clear? So this is the fundamental difference between hypertonic and isotonic solution here. Is that clear? Okay, after that I'll be moving towards the next thing of today's discussion, that is the reverse osmosis. So what we have seen in osmosis, that so you had a semi-permeable membrane, right? This one is semi-permeable membrane, and here concentration of solute was C1 and here it was C2, means partial osmotic pressure was pi 1 and here let's say pi 2. So okay, so water molecules will be there. So earlier what was happening, water molecules was moving from this side to this side, and this is case of when C1 is less than C2, right? But in reverse osmosis what happens actually, in reverse osmosis, obviously let's say concentration here is C1 and C2, but you are applying a pressure large here, right? So pressure is being applied. So due to this particular region, again concentration C1 is less than C2, but here what will happen, the solvent will start moving from higher concentration side to the lower concentration side. Is that clear? And you can see that partial pressure delta P will be greater than, means pressure difference will be greater than, if delta P is greater than delta pi here, then the reverse osmosis will start taking place. Is that clear? And what is delta P? Delta P is your P1 minus P2, or you can say delta P is equals to P2 minus P1, and delta pi will be equals to obviously pi 2 minus pi 1. So when reverse osmosis will happen, when P2 minus P1 is greater than pi 2 minus pi 1. So this can be a questions that which of the following options are correct about the reverse osmosis. So you can say that the pressure difference that is being applied should be greater than the this one. So what is pi 1? Pi 1 is the here there will be a pi 1, here there is a pi 2. So the value of pi 1 can be written as C1 RT1. Let's say if temperature is here T1 and temperature is here T2, and you can write pi 2 is equals to C2 RT2. So if I am assuming when 2 factor is equals to 1, means there is no association and dissociation case, right? Okay. So in case of reverse osmosis, you have to apply more pressure compared to the osmotic pressure, something like that. Now I will be talking about the permeability. That is denoted as PMI. So permeability can be defined as flux upon dP divided by dx, right? So you can write flux divided by gradient of driving force. So here driving force is pressure, that's why there is a gradient of driving force, that is del P by del X. Okay, so permeability can be defined like that. Now since we have seen that in reverse osmosis and osmosis, for reverse osmosis I have already told you that delta P should be greater than delta pi. And now the most important thing that can be asked here, that is solvent flux and solute flux. Sometimes they used to ask these things. So obviously, if you recall this diagram for the reverse osmosis, so what is happening here, there is a semi-permeable membrane again, and due to the semi-permeable membrane we are applying a pressure here greater than, this is P2 and this one is P1, right? So again osmotic pressure here is pi 1 and pi 2, and concentration is C1 C2, temperature is T1 and T2. Is that clear? And we have seen that delta P should be greater than delta pi, and the reverse osmosis will start taking place and solvent molecule will start moving from this side to this side. So now the thing is that, what is the first thing? Second thing is that one more important thing that will come here, that is if multi-component system is there, if multi-component system is there, how can calculate pi? Pi, that is osmotic pressure, that is equals to summation of I CRT, right? Summation of I CRT. Lots of component can be there, and you know the concentration of all of these component and what is the Van2 factor of all of these component, and you can use this thing. Now coming to the water flux, water I'll be talking about, that is a solvent. Flux equation, that is your NW, right? So let's try to write that what is NW, water flux equation, that is your BW into delta P minus delta pi, where delta pi. So delta P is your pressure difference and delta pi is the partial osmotic pressure difference. Is that clear? And NW is the obviously solvent flux unit is flow per unit area. And what is BW? BW is the water permeability coefficient, right? That you must be knowing these things. And sometimes BW can be written as BW bar divided by LM. So BW bar is permeability and what is LM? That is the membrane thickness. So there is a relation between permeability and permeability coefficient. So permeability coefficient is BW, that is can be written as BW bar, that is permeability divided by LM, that is the thickness of the membrane. That is also very important parameter, right? So if I want to write water flux, that can be written as now BW bar divided by LM, and obviously you can write delta P minus delta pi, partial pressure difference minus osmotic pressure difference. Okay, now coming to the next part, that is the solute flux. How can we write solute flux? The equation of solute flux can be written as NS is equals to P bar MS into C1 minus C2. Okay, so here you have seen that this kind of things was there, and where this was a semi-permeable membrane and the concentration here was C1 and C2. So concentration of solute is in the left compartment is T1 and here T2, C1 and C2, and temperature is T1 in T2, and this one is compartment first, this one is second compartment, and in which semi-permeable membrane is there. So you know the concentration of the solute, and PMS is the permeability coefficient of the solute, right? So here you can see PMS is permeability coefficient of solute, and this PMS can be written as ds divided by LM, where ds is diffusivity solute. Is that clear? Okay, all of these things. Now I'll be talking about what is the relation between solute flux. So there is direct formula that solute flux ns is equals to nw solvent flux multiplied with c2 divided by c average. C2 is the concentration of solute in other side, right, at higher concentration side. And what is C average? C average can be written as obviously C1 plus C2 divided by 2. Okay. So C2, the concentration of solute. C2 is the concentration of solute in permeate side, and C1 is the concentration of solute in feed. NW is solvent flux, NS is the solute flux. That's it. So that is the maximum thing that can be asked in the GATE examination here only. Okay, that ends the discussion of the membrane separation process, and after that I'll be only talking about the previous year question paper, right, for the membrane separation. So in the same lecture, let's try to wait 1 minute. I'll be importing the question, and after that you will be able to understand the Okay, so here is the previous year question for the membrane separation, and you can see that the question says that in the reverse osmosis, the hydraulic pressure and the osmotic pressure at the feed side of the membrane are P1 and Pi1 respectively. The corresponding value of P2 and Pi2 at the permeate side, right? The membrane feed and permeate are at the same temperature for the equilibrium to prevail. The general equation that should satisfy. So in when we talk about the equilibrium condition, so at equilibrium what will happen? Delta P should be equals to delta pi. So either that should be equals to P2 minus P1, that is equals to Pi2 minus Pi1, or you can say that P1 minus Pi1 should be equals to P2 minus Pi2 here. So based on this, you can see your option D will be your correct answer. So this is very simple, and this was from reverse osmosis. Already I have discussed. Next question says that which one of the following represents the correct effect of the concentration polarization in the reverse osmosis. So when we talk about the concentration polarization, so what will happen? Let's say this one is the semi-permeable membrane, and if solute is this solvent is moving, so what will happen? This solute is getting deposited over here, right? So this solute is getting deposited on the surface of the membrane, and due to this particular region the flux will get reduced, right? So the water molecules that was moving from this side to this side, it will be moving less compared to the earlier condition, right, due to the concentration polarization of the solute molecule. So this particular region, what will happen? The solute rejection will also get decreased. So something like that. So here you can see that what I have told you, due to the concentration polarization, the solvent flux will get decreased. So reduced water flux, this can be your answer, this cannot be your answer, this can be your answer, this cannot be our answer. Now water flux and reduce solute rejection and increase the solute rejection, right? So obviously, since the pore is getting blocked due to this particular region, what will happen? Solute rejection will get decreased, right? So this membrane won't work very good for the reverse osmosis, so it won't work. So reduce the solute rate, right? These were the two questions that has been asked in previous year from this membrane separation, and this is very fundamental question. So if you'll go through my video lecture, then definitely you'll be able to understand and you'll be able to solve the question. Okay, thank you in the and if you have not shared my lecture, just try to share with among your colleagues, so that who the people who are not able to avail lots of paid courses, they can understand the concepts from here. Okay, thank you.